Right. I will share with you guys. Yeah.
Doctor, the presentation, how long for one group? Yeah.
Okay. I'm not sure whether I have mentioned, but I think the time allocated is around 15 minutes per group. Okay? So around 10 minutes of presentation, and then you have like maybe 5 minutes of Q&A between all. So the sequence will be like this. Group one will present first. So since the presentation will be next week, okay. Next week we will like maybe towards the end of this week, I guess on Thursday, I will decide when we should have the presentation. So that means that for one day we can have like around 2 or 3 groups per presentation. So like group one, group two, and group three, and then following day will followed by group 4 until 6, and the other day will be like group 7 and 8, so something like that. But you are welcome. I mean, it's not really necessary, but probably later on in the WhatsApp group, I will like make a schedule, like a slot. If you guys are ready and you want to present first or what, then you are welcome. Okay? Right? Any other question before we start our lecture? Other things? Okay, so today we are going to continue with chapter 6. We already started with nitrogen-based industries. We already looked at nitrogen cycle. Okay, and probably today we are going to continue with the other parts of nitrogen cycle. Okay. So as I said, for nitrogen cycle, you have like 6 major steps that you need to remember. The first one is nitrogen fixation, second one is nitrogen assimilation, third ammonification, fourth nitrification, fifth denitrification, and sixth sedimentation. Right. Basically, nitrogen cycle, it means that the process where you convert nitrogen into different types of nitrogen-based chemical. So nitrogen-based chemical can be, for example, ammonium, nitrate, nitrate, nitrous oxide, nitric acid, and of course, nitrogen gas. So all this actually occurs with a specific steps known as nitrogen cycle. We have gone through nitrogen fixation, the first one. Okay, you can have either biological nitrogen fixation, physicochemical nitrogen fixation, or industrial nitrogen fixation. Of course, the types of bacteria used for each and every fixation need to be remembered. So, like for example, for biological nitrogen fixation, you will use symbiotic bacteria like Rhizobium, and the few examples, hopefully you can remember. Physicochemical actually involve 9 biological methods. This is more or less using chemicals, like when nitrogen gas reacted with ozone or oxygen, it will form nitrogen oxide. And then after that, it can be like oxidized or forming nitrogen dioxide and other things. Okay. Meanwhile, for industrial nitrogen fixation is more or less on the industrial process that involve which at the same time produce nitrogen-based compound. In this case, we are taking an example for the production of ammonia from Haber-Bosch process. In Haber-Bosch process, you are going to react nitrogen with hydrogen gas, which at the end will result you ammonia. And this process is very much exothermic. It involves a use of high pressure and high temperature with the presence of ion catalyst. Today, we are going to continue with nitrogen assimilation. In this process, inorganic nitrogen in the form of nitrates and nitrates and ammonia is absorbed by a green plant via their roots, and then it is converted into nitrogenous organic compounds. Nitrate are first converted into ammonia, which combine the organic acid to form amino acid. So these amino acids are used in the synthesis of proteins, enzymes, chlorophyll, nucleic acids, and others. So assimilation, I believe this you have learned during your high school in science. The process actually involves where the products of nitrates and ammonia is being consumed by plant. Okay, and from there it will convert this nitrogen-based chemical into amino acid. So amino acid, you know, it is the main building block for the production of proteins, enzymes, nucleic acid, and others. Okay, the third one is ammonification. Looking at the name itself, you know, this is actually the production of ammonia. It is a process of releasing ammonia by certain microorganisms utilizing organic compounds derived from the dead organic remains of plant and animals, and excreta of animals is like the livings, the waste of animal lah. Okay. Of course, in this case, there's a type of bacteria that normally involved in this, I think, step. Normally, actinomycete and also bacillus, bacillus type microbes could be useful for the ammonification. So what you can see over here, plant or animal that have been decomposed by soil bacteria, it will actually form ammonium. Okay, so plant or you have like rotting animals, dead plants or dead animals, it will be decomposed by aerobic and anaerobic bacteria and fungi, and finally it will convert it into ammonia. Okay. The next, for nitrogen cycle, you will have nitrification. Nitrification is a process of enzymatic oxidation of ammonia to nitrate by certain microorganisms in soil and ocean. So earlier we have seen how ammonia being produced. Okay, it can be by ammonification, and when this ammonia being produced, it will actually undergo enzymatic oxidation to form nitrate. Okay. Right. So of course, it involves bacteria. The type of bacteria that is used in this case is Nitrosomonas. Okay, that actually convert ammonia into nitrates, and Nitrobacter that oxidize nitrates into nitrates. Okay, so you will have this equation. I mean, the formation of ammonium. Ammonium, and I think maybe the equation is not balanced. It should be NH4 plus. NH4 plus, and then you can produce NO2 minus plus with H2O. I think 2 is missing over here, plus energy. NO2 minus plus with O2, we will produce NO3 minus plus energy. Okay. Then should write it. Let me write it. Okay, so as I mentioned over here, it have like 4. Okay. This is actually an oxidation process. 2, right? Yeah. So for from ammonium ion oxidize, because this is actually enzymatic oxidation. Enzymatic oxidation, it means that oxidation process that involve bacteria. This bacteria function as like probably like an enzyme to facilitate the process of conversion. Next, you have denitrification. Denitrification is the reduction of nitrates back to the largely amount of inert gas. So after you have produced NO3, okay, so denitrification is actually to form N2, okay, back. All right. So how the process goes? Um, this is also not balanced. I mean, it should be like 3, 2, 0, then nitrogen oxide, and then finally it forms nitrogen gas. Okay, so there are some denitrifying bacteria used, like for example, Thiobacillus denitrificans, Micrococcus denitrificans, and Pseudomonas aeruginosa. Okay, so all these bacteria actually involved in converting nitrates into nitrogen gas. So hopefully you guys can differentiate the difference later on. And finally, we have this sedimentation. So sedimentation, sometimes nitrates of soil are locked out in the rocks while they are washed down to the sea or leached deeply in the earth along with percolating water. This phenomenon is called sedimentation. Of course, you have heard about sedimentation, pemendapan in Malay. If you go to like any rivers or uh, sea area, if there is any erosion or anything that actually cause a soil leaching, so it will goes into water, and you will see that after it reach at the end side of the river or what, it will be deposits or it will be sedimented. So this actually where most of these nitrates containing soil will be actually deposited, and the process of nitrification, denitrification, or what still can happen over here. Okay, I guess for more info you can watch the YouTube video provided in the link. Any questions so far for nitrogen cycle? Anything that you want to ask? Right, so we are moving on to the types of nitrogen-based industries. Okay, of course, for this chapter, we are going to concentrate on a few different chemicals. The first one is ammonia. Then you have ammonium nitrate, third, urea and nitric acid. You know, all these chemicals listed here mainly used as a active ingredient in fertilizer. Urea, ammonia, nitric acid, of course, it can be used for other things, for nitration and others. And then another thing, ammonium nitrate. Anyone knows what's the function of ammonium nitrate? Anyone have a clue? Anyone have an idea?
Baja kan doktor?
Apart from producing fertilizer, ammonium nitrate especially, ammonium nitrate. Not sure. Actually, ammonium nitrate can be used as explosive. So this one you maybe heard. People are producing explosive from fertilizer. The types of chemical that is normally used is ammonium nitrate. Okay, right. So when we discuss about the production of ammonia, as I mentioned earlier, this is the process that we have heard even during high school, Haber process. Okay, probably I can share a little bit about the process. And the process of producing ammonia is basically developed by a German chemist named Fritz Haber. Okay. At the beginning of 20th century, there was a shortage of natural occurring nitrogen-rich fertilizers such as chili, saltpeter, which prompted the Japanese chemists and others to look for a way to combine the nitrogen in air with hydrogen to form ammonia, which converting convenient starting point of the manufacturing of fertilizer. This process was also an interest for German chemical industry as Germany was preparing for World War One and nitrogen compounds needed for explosive. So this chemist actually born Jewish, but surprisingly he worked with the Nazi, okay, to develop a chemical that can be used for fertilizer, which also in the same time, I mean, the main purpose of Nazi is to produce explosive. The hydrogen of, I mean, for the ammonia synthesis was made by the water gas process, okay, which involve blowing steams through a bed of root hot coke, resulting in the separation of hydrogen from oxygen. The nitrogen was obtained by distillation of liquid air and then by cooling the compress and compressing the air. All right, so what things that you need for the production of ammonia? Of course, the raw materials actually comes from various ways. You can actually produce nitrogen from atmospheric air because what we have learned in chapter 2, you can actually separate nitrogen, you can filter off or you can purify nitrogen, and then hydrogen can be produced via various ways. I guess you have heard about, I think, water gas shift process, which also you learn it in chapter 2. Other than that, partial oxidation process, which also produce hydrogen gas. So all these methods have one thing in common. Hydrogen is basically coming from natural gas. So even for partial oxidation, water gas shift process is also using natural gas, okay, or hydrocarbon as the raw materials, and then you react it with steam, and after that it will form hydrogen gas and others. Okay, so once you have nitrogen gas and also hydrogen gas, the mixture is compressed. It will be compressed at about 300 atm and heated at about 550 degrees Celsius. The mixture of nitrogen and hydrogen is passed over a catalyst, which in this case iron. Some of ammonia will be formed. About 10% of the mixture of gas will leaving the catalyst chamber, that is ammonia. When the mixture is cool, the ammonia will turn into liquid. Then you will have liquid ammonia. Okay? Of course, the unreacted nitrogen and hydrogen can be used again for the production. The hydrogen for ammonia synthesis was made by water gas process, a Carl Bosch invention, which involved a blowing of steam through a bed of red hot coke, resulting in the separation of hydrogen from oxygen. The nitrogen was obtained by distillation of liquid air and then by cooling and compressing the air. Enough steam is used to react at about 45% of the methane, and the rest of the methane is reacted with air. So this is actually the first things that you can see. I believe this equation or this reaction is not alien to you. You have seen it in chapter 2, how you can produce hydrogen gas, where you have, in this case, a shorter hydrocarbon, like for example, methane, react with steam in excess, okay, in the presence of catalyst and also at high temperature. This is the first process, okay, known as a reforming process, okay. So when you have carbon monoxide plus with hydrogen gas, okay, this will be used later on, okay. In fact, if you have methane react with oxygen plus with nitrogen in the presence of nickel catalyst, it still can form carbon monoxide plus with hydrogen plus with nitrogen gas. All the carbon monoxide in the mixture is oxidized to carbon dioxide using steam and in the presence of iron oxide catalyst. Okay, so this could be the other thing, because earlier on you will see that apart from producing hydrogen gas, it is also producing carbon monoxide. So this carbon monoxide can further react with steam to produce carbon dioxide plus with hydrogen gas. Okay, so carbon dioxide is removed by a suitable base so that only nitrogen gas and hydrogen gas will remain and used in the production of ammonia. In ammonia production, the hydrogen and nitrogen are mixed together in the ratio of 3:1 by volume. Okay, so which one is 3, which one is 1? Of course, by looking at the formula, you know that 3 volumes of hydrogen is needed compared to 1 volume of nitrogen, and compressed at around 200 times atmospheric pressure. All right, so another thing is just to simplify what we have seen just now. Okay, the reaction actually involve nitrogen and also hydrogen. Temperature used is around 450 to 500. Pressure used is quite high, okay, around 250 atm, or sometimes equivalent to 350 kilopascal. A catalyst that is used in this process is normally use a metal oxide, like magnetite. And osmium is a much better catalyst, but is rarely used because it is very expensive. This process produces around 10 to 20% of ammonia. I mean, the Haber process didn't produce like 100%. It's just producing around 10 to 20%. The rest is actually unreacted nitrogen gas and unreacted hydrogen gas, which can be reworked on to produce ammonia. The reaction between nitrogen gas and hydrogen gas is very much exothermic. The delta H value is around minus 92 kilojoule per mole. And things that you also need to consider is the pressure condition. By increasing the pressure causes the equilibrium position to move to the right, resulting in a higher yield of ammonia since there are more gas molecules on the left-hand side of the equation. Then there are on the right-hand side of the equation. Increasing the pressure means that the system adjusts to reduce the effect of the change. That is to reduce the pressure by having a few gas. So in this case, actually, why we need higher pressure is because both reactants is basically gas. So when you actually compress it, so when you compress, it will actually produce a higher pressure. Okay, when you compress, actually it will reduce the volume, okay, the volume of the gas, and then the particles that contains in hydrogen or probably in nitrogen gas can easily be collide with each other to form a product. Meanwhile, the temperature condition, decreasing the temperature causes the equilibrium position to move from right, resulting in a higher yield of ammonia since the reaction is exothermic. Reducing the temperature means the system will adjust to minimize the effect of the change. That is, it will produce more heat since the energy, it is a product of the reaction and will therefore produce more ammonia gas as well. However, the rate of the reaction at the lower temperature is extremely slow. So a higher temperature must be used to speed up the reaction, which results a lower yield of ammonia. Okay. So in this case, as we actually increase the temperature, this what results a lower yield of ammonia because you have like more heat produced. Then I think for the production of the product, I mean you have like a very little. Most of the reaction is actually related to the increase in energy, not actually in the production of products. Okay, so as the temperature increases, the equilibrium constant decrease as the yield of ammonia decrease. Another thing you should consider is the rate. So rate consideration, a catalyst such as iron catalyst is used to speed up the reaction by lowering the activation energy so that nitrogen bond and hydrogen bond can be easily broken. Increased temperature means more reactant molecules have sufficient energy to overcome the energy barrier to react so that the reaction is faster at a higher temperature, but the yield of ammonia is low as discussed above. A temperature with a range around 400 to 500 is a compromise designed to achieve acceptable yield of ammonia around 10 to 20% within the acceptable time period. All right, at 200 degrees Celsius and pressure above 750 atm, there's an almost 100% of conversion of reactant to the ammonia product. Since there are difficulties associated with the containing larger amounts of material at this high pressure. Lower pressure at around 200 atm is normally used. By using pressure around 200 atm and temperature around 500 degrees Celsius, the yield of ammonia is around that, while the cost and safety concern in building and operating condition will be minimized. Because actually, if you want to increase the yield, you can actually increase the pressure and others. But the problem is it will be risky because if you deal with a very high pressure, then what happens if you have a leakage? Then of course this could be like atomic bomb to you. During industrial production of ammonia, the reaction never reach equilibrium as the gas mixture leave the reactor, okay, and cool to liquefy and remove ammonia. Right. So the remaining mixture of reactant gas are recycled through the reactor. The heat released by the reaction is removed and used to heat the incoming gas mixture. So manufacturing procedures for Haber process, of course, you need to consider manufacturer of reactant gas. In this case, for the production of nitrogen gas and also production of hydrogen gas. Purification of reactant gas, purification of nitrogen and also purification of hydrogen gas, which you have learned also. Compression, this is also important because when you want to mix these two things together, you need to compress it. As I said, if you increase the pressure, then the chances to react will be higher. A catalytic reaction, because in this case, the use of catalysts like magnetite or iron oxide can reduce the activation energy required to convert reactant to product. And then recovery of ammonia form, how you can actually recover ammonia, and finally recirculation. Recirculation actually means that the unreacted nitrogen and hydrogen can be reused back for the production of ammonia. So you have, I think, a YouTube link over there, which you can copy and you can use it to watch how the production of ammonia can happen. There's also another methods for production of ammonia. It is named as Kellogg process. So in Kellogg process, it's slightly different with Haber process, because in this case, you will see that the type of reactant used is basically natural gas. And you need to like purify the gas first. You will put in a preheater, and then you will remove the sulfur using desulfurizer. And then what happened is it will react with steam first. So what happened? Natural gas react with steam. The same thing actually, it will produce carbon monoxide or carbon dioxide with hydrogen gas, and then there only you can have like the other things. The other reactant is basically reacting the fuel gas. I think this is where you get the hydrogen, okay, and after that, by reacting these two things together, you can actually get liquid ammonia, okay. So I think Kellogg process is just for your information. I don't think that you have to like memorize the scheme or the PID diagram for this one. Most important for the production of ammonia, just remember about Haber process. But of course, I provide you with a link as well to watch the video how you can actually produce ammonia from Kellogg process. Right, the uses of ammonia can be various. It is mainly used in agricultural industry because you know ammonia is the active ingredient in fertilizer. So of course it will be an important things in agricultural industries as well as fertilizers. Okay, and ammonia is also used as a source of protein in livestock. Source of protein for livestock, for example, cow, sheep, right? So ammonia can also be used as a pre-harvest cotton defoliant, okay, and antifungal agent on certain fruits and as preservative for storage of high moisture corn. Okay. So the dissociated ammonia is used in such a metal treating operation as nitriding or carbon nitriding. So bright annealing is heating process, furnace brazing, sintering, sodium hydroxide descaling, atomic hydrogen welding, and other application where protective atmosphere is required. Then this will also use ammonia. Apart from that, ammonia is also important for manufacturer for the production of nitric acid. Okay, it is also used for the production of soda ash. If you still remember in chapter 4, okay, for the production of soda ash, you need to react it with ammonia. Dyes, pharmaceutical, such as sulfur drugs, vitamins, and cosmetics. Synthetic textile fibers, such as nylon, rayon, and acrylics, also use ammonia. In petroleum industry, it use ammonia in neutralizing the acid constituent of crude oil. Ammonia is also used in mining industry for the extraction of metals such as copper, nickel, and molybdenum. Okay, so this is also what we have learned in chapter 4, hydrometallurgy. Okay, you will use you will use ammonia in this case to extract, less reactive metal like copper and nickel. Ammonia is also used in several areas such as water and wastewater treatment to control pH in the solution, and then ammonia is also can be used as a stack emission control system to neutralize sulfur oxide from combustion. Okay, so many things. It can also be used in photochemical processes such as white printing, blue printing, used in refrigerant, in industrial refrigeration system, and is also used in rubber industries because if you still remember, once you do rubber tapping, this I think kids these days didn't know about rubber tapping. So after you have tapped the rubber, how do you going to? How are you going to store it? Okay, so normally the rubber tapper will include vinegar. So when they put vinegar, what happened is it will be coagulate. It will be coagulate and it will form a solid rubber. Okay, and how actually you want to like dissolve back and make it into a solution back? So you just add ammonia. So when you add the ammonia, the rubber latex can be dissolved and then it can be put in a mold or others. And finally, I guess the use of ammonia is also important in pulp and paper industries because ammonia have these alkaline properties. So it can actually be used to remove out most of the lignin or other things, okay, leaving out a pulp that is rich with cellulose for the production of paper. In food and beverages industry, ammonia is used as a source of nitrogen needed for the yeast and microorganisms. The decomposition of ammonia serves as the source of hydrogen for some fuel cell and other applications. And ammonia is also used by leather industry for as a curing agent, okay, as a slime and a mold, preventative in tanning liquors, and as protective agent for leathers and furs. Okay, so weak ammonia solution also used for household cleaning and also detergents. Right. Any questions so far for ammonia? Anything that you want to ask before we move on to ammonia nitrate? Anything? All right. We are moving on to the next one, production of ammonium nitrate. Okay. Of course, as I said, the use can be as follows. It can be used for fertilizer because it contains high nitrogen content, around 33%. It's cheap and it is simple to produce. At the same time, ammonium nitrate is also used for explosive. Okay, so ammonium nitrate is actually made by reacting nitric acid, okay, made from the oxidation of ammonia and ammonia. Okay, so nitric acid, when you react with ammonia, it will form ammonia nitrate. So the production of ammonium nitrate is basically follows Stengel process. So in Stengel process, what you need to do is that you need to preheat ammonia and also nitric acid. If it goes into the reactor, okay, and this actually will be extremely hot, and the molten ammonium nitrate will be air flown. It will be like spray into the cooling chamber, and after that it will form frills. Frills is like a pellet or like a small crystal structure. And when it goes to the cooler, it actually make it even harden. And frills sometimes can be used to screening, coatings, and also packing. Meanwhile, the next one is basically the production of urea. The commercial synthesis of urea involves the combustion of ammonia and carbon dioxide at high pressure to form ammonium carbamate, which is subsequently dehydrated by the application of heat to form urea and water. Okay? So in this case, you have ammonia reacted with carbon dioxide. It will form ammonium carbamate. Okay, and it will be hydrated. Okay, to form ammonia plus with urea plus with water. So there's two reactions involved over here. Okay, the first one is actually the formation of ammonium carbamate, okay, with the enthalpy around minus 155 kilojoule per mole. And then the second one is the production of urea, okay, by dehydration process. Okay, the dehydration of ammonium carbamate produce urea plus with water with the enthalpy values around 42 kilojoule per mole. Right. The first reaction actually for the production of ammonium carbamate, it is fast and isothermic and essentially goes to the completion under the reaction condition used industrially. Reaction 2 is more slower and endothermic and does not go to completion. The conversion is usually in order of 50 to 80%. The conversion increases with increasing temperature and with the increase of ammonia to carbon dioxide ratio, and the decrease with increase of water to carbon dioxide ratio. Okay, so for the production of urea, the type of process is known as Smampogeti process. Smampogeti process, the same thing as what we have explained earlier. The first reaction is basically the production of ammonium carbamate, and second one is the dehydration. So you can see over here, okay, the ammonia, the ammonia will be like used, and then it will goes into the reactor, okay, and then react with carbon dioxide to form ammonium carbamate. And later dehydration, what happens is it goes into the stripper, so you can actually collect water at the end, and the condensed material will be stored as urea. Okay, so there's a few videos link that I put over here just to show you for the production of urea. If you have time, you can watch the video as well. Okay, so the block diagram of a total CO2 recycling stripping of urea process, and the block diagram of a total ammonia recycle stripping urea process. So in this case, you have CO2 and ammonia recycling process, how you can actually recycle carbon dioxide and also ammonia from urea production. Okay. This is just for your information. I don't think that you have to memorize this thing lah. Okay. And of course, what will be the importance or the uses of urea? So urea is also known as carbamide or carbonylamine, is marketed as a solution or in solid form. Most urea solution produced is used in fertilizer mixture with a small amount going to animal feed supplements, and most solids are produced as pills, or granules for use as fertilizer or protein supplement in animal feed and in plastic manufacturing. 5 US plants produce solid urea in crystalline form. About 7.3 million megagrams, okay, of urea were produced in the US in 2010. About 85% was used in fertilizer, 3% in animal feed, and the remaining of 12% is used in production of plastics. Okay, I guess for the production of nitric acid from Kellogg Process, we can actually continue this tomorrow. Okay, and so far, do you have any question, anything that you want to ask? Ada apa-apa soalan? Any question from the floor? Oh, Langkawi. Sorry, explosive. Thank you, Langkawi. All right. So, if there's no further question, then I guess we are going to call for the day. As I said, tomorrow we are going to have quiz 4 for extractive metallurgy chapter, and yes, probably if you have any question regarding on your presentation or your report, you are free to ask me privately, or you can ask during the class tomorrow. So, okay, guys, I guess thank you very much for your time and attention. So remember to fill in your attendance. I guess maybe this few weeks I noticed that the numbers of attendance field is kind of less. So please remember that your attendance via Google form is important. Even though you watch it online, you still need to fill in the attendance. So, okay, thank you very much, guys, for your attention again. I wish you have a great day today, and selamat berbuka puasa to those who are fasting, and hope to see you tomorrow afternoon 12. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
You're welcome.